All right. All right, everyone. In today's teaching lesson, we are going to be looking for similar hotel names using Python. We're going to use a specific technique called cosine similarity. Okay, this looks at the angle between two vectors and measures the dot product of the magnitude of those vectors. So what's a vector? It's a small line with an arrow at the end of it pointing in the direction that the line is headed. And we look at the angle between these two vectors. So if it's a very similar angle, the vectors are pointing in the same direction, they're very similar. That's high cosine similarity. And low similarity is if the vectors are pointing in opposite directions, maybe orthogonal, that would be perpendicular, or completely opposite, that would be very different, right? So we're looking at similarities or differences in words. So spelling of words, how words are formed, how they sound, how they're spelled out, the vernacular, and the text of the words. Okay, so I'm going to go ahead and load some sample data that I have saved on my desktop. I'm going to give you the source of this data. I'm going to give you all of the source code as well. When I post a video, I'll post the source code so you have everything. You don't have to worry about all the nuances and all the details right here, right now. You can just sit back and enjoy, understand the concept, and you'll have the code so you can copy and paste it and run it in your own Jupyter Notebook environment. Okay, I'll do all of these teaching sessions in Jupyter Notebooks. I like the look and feel of it. It's pretty scalable, scales up and scales out well, and you can create some pretty cool interactive dynamic graphs. I've got a few videos that I've already posted on YouTube about dynamic graphing and plotting and charting. So that stuff is pretty cool. Check it out if you have a chance. So we have our data frame. We have the name of the hotel, the address, and then a description of the hotel. Okay, we're going to do a small exercise right here just to clean up the text to make sure and everything is nice and tight and crisp and clean. We're going to do some word counting, look at the average length of word, the min, max, and get some features and some attributes of these words. Okay, so we have a technique or a library called stopwords. It contains all kinds of English stopwords, which are basically words like the, and, or, but. Things that you see all the time that are used in sentences constantly, but doesn't add a lot of meaning or purpose to the sentence. If you're telling me something about apples or IBM or whatever, a window or a soccer player or something like that is giving me some context about what the sentence is going to be about, or what the article, or what at least the paragraph is going to be about. But words like I, and, or is not adding anything meaningful or substantial to the context of the meaning of the word, right? So we're going to remove those so we have just the pure significant meanings of the word. So we have description clean. I've cleaned up that first column, so you see the difference already. 11th Avenue, in bed, and breakfast. So 11th Avenue, in bed, breakfast. That's description clean. We got rid of and because it's not adding anything, right? Ace Hotel Seattle, description clean. That's the same because that is descriptive of what that thing is, right? So let me see if we have another Ballard Inn. Okay, nothing's removed there because all the words have meaning. And America's Best Inn, Shoreline, Seattle North. Okay, so the only thing taken out there was the backslash. That was unnecessary. So I guess in the first example, that is the most relevant. The word and was taken out because it doesn't add any meaning or context, right? So that has been cleaned up, and everything is in the same lowercase format now. So that's helpful too. We want to be consistent and persistent with these types of things whenever we're analyzing anything with words. So I'm going to look at the description clean. That's a new column I just created. Anything that's NA or missing, I'm going to fill with just a blank. A blank is more useful than a nan. A nan is nothing. NaN is not a number, but that's not very helpful. A blank is just a blank. That's actually more useful than a nan. So we're going to do a little more cleaning and then look at the TF-IDF vectorizer for all of these words. So text frequency is abbreviated TF. That's how frequently a term shows up in a body of text. And IDF is inverse document frequency. We're looking for the inverse frequency of words in documents. So if you have a word like apple and it shows up in one document, you could assume that the document has something to do with Apple, the computer company. Red apple or green apple, that's a fruit, right? Something like that. If the document, again, has words like I, and, is, or, that's not adding anything of significance. So those words will probably show up in multiple documents or in all the documents, but they're not adding any meaning. So we are going to disregard these things. Okay, it's kind of like doesn't really have any value, not any value whatsoever. So we're gonna just drop those things. Okay, so let me refresh this cell, moving down, and we have our nice cleaned up text here. We have the name of the hotel and address, and I am looking at the similarity now of hotel names. Let me go up a little bit. Most similar is the name of my function. Okay, you can see how this works right there. Double click to highlight it. Okay, we have the name. That's the name from the data frame of the hotel, and cosine similarities is calling itself as a parameter. So that's what we're looking for now. The cosine similarity of Hyatt Olive 8 Hotel. What is the most similar name to Hyatt Olive 8 Hotel? And we can see here we have these Hyatt hotels printed here. So Hyatt House Seattle. Okay, so Hyatt at Olive 8, that's what we're looking for. So we're getting Hyatt and Hyatt Regency. So those are similar. Hyatt Place Seattle, that's similar. Grand Hyatt, similar. Another one is Hyatt Regency Lake Washington at Seattle Southport. Okay, so Hyatt shows up in all of these other hotel names because it's substantially similar to Hyatt at Olive 8. That was the search term. Okay, so pretty cool, right? That's sort of that's an excellent example of cosine similarity. We're sort of doing fuzzy matching. I have another video about fuzzy matching, and we're matching words based on the fuzziness or the similarity of words to other words, right? So we're finding all the like words, which is pretty powerful. It's not anything like a Control F in Microsoft Word when you're finding an exact search or some kind of wildcard search. This is really next level stuff where you're really looking for mathematical representations of words based on cosine similarity or, again, dissimilarity. Now we'll see an example of a dissimilar hotel name. So this is least similar. Again, hotel similarities. I'm sorry, least similar is the function name. Let me go ahead and highlight that. If the mouse will cooperate. A little bit laggy here. I know why, and I can't do anything about it. So you have the name and the cosine similarity again. But in this case, we were looking for the least similar hotel names to Hyatt at Olive 8. And it turns out it's Pension, Nichols Bed and Breakfast, Pike Place Luxury Suite, Quality Inn and Suite Seattle Center, Radisson Hotel Seattle Airport, and Ramada by Wyndham at SeaTac Airport. None of those sound anything like Hyatt at Olive 8, right? So those are dissimilar. So we saw an excellent example of hotel names that were similar to a search name, and we found the opposite case where hotel names were very dissimilar to the search term, which was Hyatt at Olive 8. Okay, so hopefully that was enlightening. Hopefully you learned something new today. I think this stuff is pretty cool. I think it's pretty interesting, and I really get a kick out of it. So hopefully you do too. Thanks for your time, and as always, have an excellent rest of your day. Thank you, everybody. Bye.